Good morning, good afternoon, and good evening. Welcome to today's HiveMQ webinar, where we'll talk about how HiveMQ Pulse is changing smart manufacturing. My name is Mohan Kampella. I'm the VP of Product Marketing here at HiveMQ. Once again, thanks for giving us your time today. And before we get started, just want to mention two quick housekeeping notes. We are recording this webinar, and as you go through the webinar, if you have questions, please post them in the Q&A section of your Zoom webinar panel. And then I know that we have a super exciting and engaging webinar coming up. So based on the time, we'll do our best to answer those questions. All right, with that, let's meet today's speakers. If you've been in the industry for any amount of time, I don't really think you need an introduction to Walker Reynolds. But having said that, I will go ahead and talk about him just briefly. Walker, thank you. Thanks for being here. So Walker Reynolds is an industry IoT and Industry 4.0 thought leader, speaker, and educator. He's the president and solutions architect at 4.0 Solutions. Walker's career spans more than 20 years with time spent in mining, steel, printing, and tier one automotive prior to transitioning into systems integration and ultimately becoming a business owner and educator. Great to have you here, Walker.
Thank you. Appreciate it, man.
Yeah. Our second speaker, who may also not need an introduction if you're familiar with HiveMQ, is Magnus McCune. Magnus is HiveMQ's VP of Product Strategy and Innovation. He's a passionate technologist with a strong background solving complex business and technical challenges through the design, implementation, and operationalization of cloud and edge technologies. His expertise extends to network, cloud, and infrastructure architecture, cloud native solutions design, and large scale automation projects. At HiveMQ, Magnus has also been closely involved with many of our customers over the last few years. So if you're a customer who's joining, I'm sure you've worked with or interacted with Magnus in the past. Magnus, welcome, and over to you.
Thanks so much, Mohan. I'll briefly cover an agenda of what we're hoping to cover today, and then I'll turn it over to Walker to introduce the industrial data problem and kick off our chat today. So as I said, we've completed introductions. I'll hand it to Walker in a moment to talk a little bit more about the challenges of bringing together industrial data and how we're looking to solve those. And then I'll speak a little bit on HiveMQ Pulse. And then the piece we're all excited about is we'll hop into a live demo environment and wrap up with some customer use cases that are tied around that, and then move aside to our fireside Q&A where Walker and I will continue the conversation. And once we have time we'll answer and ask some questions from the audience as well. Thanks so much. Walker, really, I'm hoping you can take us through a little bit of what are the struggles our prospects and customers are experiencing around industrial data. Why is this so challenging? Why is this such a pervasive issue? And how have we arrived here?
All right, so thank you for having me first off. So I've actually done something here that I don't normally do when I speak or do a webinar, and I actually wrote down all of my thoughts. I actually highlighted, and the reason why it was my goal at Prove It in February. You guys announced Pulse, right? You guys, and by the way, it was a masterclass in how do you launch new technology. It created enormous amount of buzz, and one of the things that I took away from the announcement of Pulse, which by the way, I was slightly aware of what Pulse was, but I actually, just like everyone else, I got to see Pulse, the announcement with everyone else. And my takeaway was, this is all anyone's going to be talking about. Like, and by the way, it was the line at your guys' booth was literally right after you announced Pulse, was around the corner. It's all anybody wanted to talk about. So I want to talk about why, though. Like, why is it I said that? Why did I say this is all anyone's going to talk about? And it can be distilled down into the industrial data problem. The team just told me this morning, it's kind of funny. We have our most popular video we've ever put on our YouTube channel. It's called SAP is Dumb. And in my morning video here, it's just a little short, a 30-second clip. It's actually kind of out of context, but it's our number one, it's had just ridiculous, hundreds and hundreds and hundreds of thousands of views. There was a comment in there where there was a guy who said I was an idiot because My argument that SAP is dumb is that SAP is too rigid. It tries to enforce rules. It tries to enforce rules on manufacturing operations that you cannot possibly live up to. At the end of the day, that's what I say. And what happens is when manufacturers, when producing on the plant floor runs up against those rules in the ERP system, the ERP system doesn't win. They do whatever it takes to produce. Therefore, that's how you know what the priority in a business is. It's actually production. All right. Well, I want to talk a little bit about why that's a problem. Like in software, it is very easy to create object-oriented software where the back end, I have master data, which is essentially data models and information models. I have an API that has function calls that go and retrieve that data and add new data to it. And then I have a UI that interacts with the software, and it's very object-oriented. I could create an object that's a triangle in the back end. I could create an API call that's in the shape of a triangle in the API, and I could create a visualization that's a triangle in the UI, and they are all congruent to one another, okay? The industrial data problem is that is not possible for 99% of data applications in industry. You can't do that. So what you have to do is you have to capture the data as it happened. You have to capture the reality, okay? You model what you can on the edge, which is generally automation models. It is generally P&ID loops. It is generally sensor models, okay? But business models don't live on the edge. So a business model would be a bill of materials. Okay, that is a business model. You have to get that somewhere else, much higher up the stack, okay? So the industrial data problem can be distilled into 4 points, okay? So real world struggles with data quality, context, and scale. What I just talked about here is context. The context doesn't exist everywhere in an organization. You have to add context to data to convert it into information. So that's number one. Number two, why do most digital transformation efforts stall, especially around unified namespace? If they do, and the answer is how do I add the additional context to my data so I can make decisions? Okay. Number three, the limitations of existing tools. This is probably the number one problem. The number one problem is the limitation of the existing tools. Okay. And building one-off solutions. By the way, the limitations of existing tools is why TPG has acquired Prophecy from GE and why they just acquired Kepware and ThingWorks from PTC yesterday. Okay. Or from GE and then PTC. That's a private equity firm that has acquired the top connectivity platform in the world and what was supposed to be the best IIoT platform in the world. The reason private equity has acquired them is because of the limitations in those tools. Okay, and now they're going to try and squeeze as much blood out of as they can. Okay, and then the last piece is the urgent need for structure, semantics, and governance. Okay, that's an IT philosophy. So real quickly, here is the industrial data problem. I'm just going to go through my thoughts here, and if you guys have questions, you can ask later at the end. So there are two fundamental premises we have to accept. All right. So number one, AI in industry 4 and 5, is going to shift our focus from spending so much of our engineering labor on building user interface, okay, which is where we spend the bulk of our time, which agents do much faster and better. They build visuals way better than we do. Okay. To shifting our human focus on connect, collect, store, and analyze, which is data operations, which is what we're talking about today, for consumption in the UI. And you have to, there's a second premise from here, which is the power of data. Okay, the second premise is found in the conversion into information we take action on. So data by itself is not really all that valuable. What we turn data into is. And what we do is we turn it into decisions. Okay. So that's data to decision. And that is so much harder to do than manufacturers realize. That is the industrial data problem. Why? Because after we have access to data, which is never, ever, ever in its perfect form, okay, for our new decision-based applications, we have to then convert many data points into information models through contextualization and normalization. This is where Pulse comes in, okay? This is the crux of what data operations to build data intelligence is. So I'm just going to run through these thoughts. Number one, data is just something that happened and went. So it lacks nearly all context. It's an event and a timestamp, okay? The power of data comes from what we can learn from data. It's not data by itself. So what we learn from data is a function of how we contextualize data points relative to other data points. So both static and ad hoc, okay? Information is something we learn from and we can take action on. Information is built from data plus context. Intelligence is our ability to learn from that data, conversion into information. And wisdom, which is what you are trying to achieve, manufacturers, wisdom is what we actually learn from the intersection of intelligence, data, converted into information. Okay? So while potential context can be quantified, so that is, what is all the context I need to make decisions? While it probably could be quantified, it's definitely not infinite. Okay? The potential combinations of data context in your application, it seems limitless. Like these are the permutations, the relationships between a sensor transition and an OEE calculation seem limitless. Okay. This is a challenge because we can't solve all of our data challenges at once. We can't contextualize and normalize just one model and then never have to worry about it again. Okay. We get smarter through data to information. We get wiser. And then the potential for what we can do grows with our wisdom, coupled with our access to more data, which we convert into information to make more decisions. So we must iterate using platforms. This is where Pulse comes in. Not build one turnkey solution using a monolith, which is why ThingWorx and Kepware just got sold to TPG, and why Prophecy just got sold to TPG, because what that challenge I just outlined is the reason they failed. Okay, that's the reason they failed. The traditional approach to data operations is called digital threading. Okay, it's called creating digital thread, the object-oriented approach. Okay, that doesn't work for nearly all applications of data because it assumes that all context can be summarized and encapsulated upon instantiation of the data model. So when I create the original model on the edge in the PLC, I could encapsulate everything I need to know in order to convert it into the information I need to make decisions. And that's just not true. It's simply untrue. Okay. So most data to information use cases have a goal of turning data into some operational or business decision. And very rarely is all the data needed to contextualize and normalize into information for decision-making found in the same place pre-modeled, which is where Pulse comes in. So for an example, this is a real world example, okay? If what I want to do is calculate OEE, mean time to repair, and mean time between failure, so I can make operational decisions, that's OEE, and I can make maintenance decisions, that's mean time to repair, mean time between failure, I need in-feed, out-feed, state, and waste from a PLC. I need the work order, the schedule, the production run, the standard rate, the runtime, and the state downtime reasons from a combination of the MES layer and the ERP. Plus, I need the failure detection time, the repair start time, the repair complete time, the asset ID, and the runtime from the CMMS layer. And that's how I would get the KPIs that allow me to make decisions of OEE, mean time to repair, mean time between failure. Okay, you have to create that contextualization after the fact. Okay, so the data in our example comes from many sources across many domains and may not exist all at the same time. This is where Pulse comes in. Okay, your ERP, for example, might get installed later, or it might get changed. Your CMMS might get installed later. It might get changed. And you have to have a platform that can react to that. Okay. So what we need to create intelligence from data, what we get from converting data to information iteratively, is the ability to contextualize and normalize across domains, data types, so transactions and events, they are different, okay? And resolutions. The rate at which data points change are different. A sensor might change 60 times per second. An OEE calculation might happen one time every 60 seconds. In order for me to unlock the potential, specifically with machine learning, which we'll talk about later, I have to have that normalized. There's got to be one OEE calculation for every sensor value. That's called normalization. Okay. Platforms that produce and consume to and from data infrastructure are perfect for this, which is where Pulse comes in. So the ideal solution is connected to live event streams and master data, plus transaction stores. The ideal solution is as close to the data pipeline as possible and can contextualize and normalize in real time and at the same speed as the data is being moved. That's where Pulse comes in. Successful data intelligence strategies couple the functional steps, which I just talked about above, with the structure, the power of UNS architecture. Okay, that is one ecosystem, semantically organized, single source of truth, and IT governance strategies, all on one data intelligence platform that supports open architecture technology. That is, the platform doesn't become a monolith. HiveMQ Pulse is a data intelligence platform that connects to transactions and sits right on top of the event streams. It has access to the data. It's as close to the events as you can get. It operates at the speed of those events, and it provides the capabilities needed to contextualize, normalize, and model data into information across domains, data types, transactions, events, ethereal, and data resolutions. And that's why I said, okay, that's why I said Pulse is all anyone's going to be talking about. Because right now, what Pulse is going to be able to do, what it can do, and the rate at which it can do it doesn't exist anywhere else in the market. It is literally the only platform that can do what Pulse can do at the rate it can do it. That is the industrial data problem.
Wow. Incredible summary, but also I really appreciate that you condensed it so well. I'm used to having conversations with you where we go for 2 or 3 hours, so I'm genuinely impressed.
Which is the reason I wrote this down, because otherwise, because we had a 1 hour hard stop. It's the reason I wrote it down.
I truly appreciate it. I mean, I think that continuous evolution that you described is really key to this, right? Which is that you're not just going to establish what this looks like once; it needs to evolve alongside you. Actually, it's a great talking point around Pulse, because Pulse will continue to evolve. We're in our availability now, but Pulse will continue to evolve as we're working through this, as we get more and more feedback from our customers. And so really just a great sort of synergy there between the evolution of how Pulse gets used and how we will continue to evolve Pulse from our end. So, I mean, to sort of, I feel like Walker did a great job of actually hitting all of my talking points, but I'll take a step back for a minute. Ultimately, our distributed data intelligence platform, Pulse, is about bringing together those live data streams, that incredibly fast data backbone that we already have with our broker technology, with a context layer that allows me to understand what the relationships are between these data points. So, and to continue to evolve that graph of data points and the relationships between them over time. So as I might start with very simple relationships like hierarchical relationships, but as I evolve my understanding of that data, I can create new relationships between those data points so that I can actually gain more wisdom, more insights as I go. And so that evolution from data to information that is data that has been contextualized, into insights and actions and my ability to actually derive value from my data, this is really where Pulse sits for us. So just briefly, who is it for? And really, there are 3 key personas. I think, Walker, we both agree there's one really key persona, which is the brilliant people on the shop floor who
Yes.
really need to actually interact with these tools. And then they have some folks who have some demands of them, is how I'll put this, which is sort of my IT and data teams. And really, for that OT team, Pulse is about helping them to hook up and model data faster, keep plants running and troubleshoot faster, being able to identify sources of data really rapidly so that I can immediately troubleshoot that, scale without multiplying pain and complexity. I mean, I think that's the thing we all run into, is some of this stuff is relatively simple at small scale. When I'm doing a lab, it's really not too painful. But when I have 100 devices that each have 100 data points, my scale and my complexity grows really rapidly. So Pulse helps to keep that in check for those.
And by the way, that was one of the key reasons Pulse is being delivered now, because as you guys were scaling the platform up, you realized, wait a minute, our broker is our Pulse has got to be able to handle data event streams at the same rate the broker does, and that is a massive challenge, which you guys now have overcome. But initially, you guys ran into a critical mass and had to go back to the drawing board, right? I mean, that is a very real industrial data problem.
Yeah, I mean, that's a great point. I mean, the interesting thing is we were doing a demo in February of this year. 10 months ago, we were doing demos on Pulse. But there's a reason it's taken 10 months for us to get here, and why we continue to evolve. And that's these challenges at scale are really quite hard.
Yeah, they're real.
And especially when you're dealing with clustered brokers, especially when you're dealing with distributed data. Some of what you'll see today, you know, some of the reactions I've gotten in the past are, oh, this seems similar to XYZ. And then we zoom out a little bit, and it's XYZ, but at at extreme scale, right? It's oh, this isn't just one site that I'm visualizing. I'm actually visualizing my true unified namespace, the entire data fabric at once. So really key to sort of keep that in mind. That ability to contextualize across domains. I've got data coming in from ERP and CMMS systems and MES systems. I have data coming from a variety of systems is really key. Another piece that's really important with us is that it plays nice with what you already have. And this is a story will continue to evolve as we gain more partners on the technology side. But it has to play nice with what you already have. There is no, I think there would have been no greater mistake for us to make as HiveMQ than to say, let's imagine that everyone will just move over to our technology, and let's imagine that everyone will just use our edge exclusively. When the reality is there are Kepware installations out there. There are thousands and thousands of Kepware installations out there. There are thousands and thousands of Ignition installations out there, and so we have to play nice with those existing systems. And as we partner, we'll actually deepen those integrations as well. And then the last thing is ensuring you can play nice with your security and compliance teams, and that you're working through the challenges that are being presented as compliance in regulated industries evolves, and whether that's the energy space or the pharma space or really all of these spaces that are evolving compliance standards. So that's on the OT side. Obviously, on the IT side, often I have a VP of data or a data analyst of some sort who's saying, "Hey, can I just get this data in a format that I'm used to? Can I just get this in something that is normalized and ready to use?" The energy, the effort that is spent today, the compute, the budgets that are spent today to get data into a format that's ready to be consumed by analytic systems is incredible. The Snowflake. There's a reason Databricks and Snowflakes are the behemoths that they are in a relatively short period of time, and that's because people are spending so much work to get data streams like operational data into a sort of normalized and ready-to-use factor. And so Pulse aims to simplify that process, and specifically simplify that process with the people who know, right? If I'm a data analyst and I'm looking at data from a PLC that's called IoT underscore data underscore sample one, I actually don't know what that means. And the only way I'm going to figure it out is to call up an OT engineer who, frankly, is really busy with something else.
And for the decision maker out there, the person who owns the budget, for the person who owns the business outcome, but they don't really understand the technology. Even the CTO, who is generally a technologist, hasn't worked with technology in a very, very long time. I mean, they've been an executive and a manager for a really long time, and they have this base technical knowledge. For those of you who are the decision makers, if you want to know the fastest way to waste your money on digital transformation, don't understand why context and normalization is really, really important, because you can trace nearly all of your failures in the conversion of data into decision to a lack of context or an inability to normalize. I mean, at the end of the day, and context is just relationships. That's all it is. If I want to predict failure, a negative business outcome, plant is not running. I want to predict every time the plant's not going to be running. The first thing I have to do is create a relationship between every process outcome that leads to the plant not running. That's context. Okay. And then what I have to do is I have to establish all the relationships that lead to all of those negative process outcomes that lead to plant not running. And once you get 3 or 4 layers down to the plant floor, you have hundreds of thousands, millions of potential relationships that you must have established. That's context. Okay. At the end of the day, but if let's say I wanted to do something really simple, like I want to predict the failure of this specific bearing. Well, I might measure that bearing 3 different ways: temperature, sonic and vibration, right? I have to establish a relationship between each of those 3 measurements and the negative outcome of the bearing failure. By the way, you don't have a thing that says, you don't have a data point that says bearing failed. There's not a place to read in the PLC that says the bearing failed. So now what you have to have is a relationship between what the mechanic put in the CMMS, which is the reason the line stopped is because the bearing failed. And then you have to train a model off of those relationships. This is the industrial data problem. And what he's talking about here, at the end of the day, if you're the decision maker and you want to know why is this so hard, I just laid out in 90 seconds the primary reason it's so hard. And you have to have a platform.
With 3 data points and 1 event from a CMMS. Like,
correct. 3 data points and 1 event. Yes.
Yeah. And that might be, I'll say nominally 24 relationships, probably more.
Correct.
Yeah, incredibly challenging. That sort of third person that this is for, and this is an interesting one. And Walker, I'm going to blame you for this problem to some degree. But we have that sort of transformation architect, that person who's been given a mandate of fixing all of this, and they've taken a mastermind class and they've learned a lot from you around needing a unified namespace. That a unified namespace is a design pattern that solves for some of these challenges. And then they go out to market, and as you described earlier, they sort of land and go, wait, there's no tool I can buy. There is no one platform I can buy to do this. And HiveMQ has for a long time now played a critical role to building these unified namespaces, the data movement layer and the integrations layer. But it doesn't have a comprehensive answer to this. It doesn't have one solution that answers all of this. And so that transformation architect who's been mandated to do this doesn't have an easy button. They don't have a big button that they can hit that says, oh yeah, I just go buy XYZ software and it fixes it for me. And Pulse is moving towards that direction. There is no easy button in life. I want to be very clear. But there is a platform now that supports a lot of those decisions, supports moving in the right direction, that assists that person in actually answering some of these questions so that they can go back to that decision maker and say, hey, I think a unified namespace might solve this for us or might help us along the path to solving some of this. And here's the tool that we need to purchase to do that. And this is really...
Well, in unified namespace, what's very important is that unified namespace gives you the first layer of context that Magnus talked about earlier, which is semantic hierarchy, hierarchical relationships. How is this production line related to the business? Well, it's in this area and it's in this site, and this is its function. Like, you create that with semantic hierarchy and parameters. But you have many other types of relationships. So we call semantic hierarchy 2D relationship. So that is essentially 2-dimensional. It goes left to right in a tree. Okay.
Yep.
But there are 3-dimensional relationships. There are multi-dimensional relationships beyond 2D. And this is where we start talking about knowledge graphing. Okay. So if I want to, this is where GraphQL comes in. This is where knowledge graphing comes in, which are 3-dimensional relationships where I can have one sensor that lives on one production line in one area in one site, but it can have a relationship to a production line that is not in its area. It's a sibling area. That is a 3-dimensional relationship. And that is something I need a platform to do. And the argument here is the market for these transformational architects, through the adoption of unified namespace, have created the market for the platform that will give you the ability to do both 2-dimensional and 3-dimensional relationships so that you can serve the contextualization and normalization of data into decision-making in your business. Now, that's just one cross-section of what Pulse actually does, but it's where everyone's going to start.
Love it. I'll talk briefly about the Pulse architecture before I just dive into a demo, because I think that's where we really want to get to. Simply put, the architecture is there are 2 components. There is the Pulse agent, which actually sits currently within our brokers. So if you were deploying a HiveMQ broker or a HiveMQ Edge or our fully managed HiveMQ Cloud, a Pulse agent sits within those elements. And live captures that data that is in motion, can interact with it while it is in stream, and is I describe it as the hands and feet of the Pulse system, is the agent. Those agents, we have plans for partnerships. They're not ready to be talked about yet, but we have plans for partnerships so that those agents will live outside of just HiveMQ technology, but that is the direction we're heading in. The next piece of this is the Pulse server, which is a centralized component that coordinates, orchestrates, and stores the metadata that represents those information models. That knowledge graph, that semantic graph that Walker described, is persisted in the Pulse server, and that is the centralized component. It's also where the UI lives, so you'll see that I'm going to connect across to the UI in just a moment. That UI lives centrally, but is interfacing with all of those agents in a really sort of well integrated way.
Are you switching slides? Because I'm not seeing the slides switch.
No, I still have that up.
Okay, perfect.
Oh,
Perfect.
I forgot I had this pulse capability slide, but I'll quickly roll through it. So the key pulse capabilities before I head over to a demo. So certainly discovery, context, and metadata, being able to add that really key relationship and non-relationship metadata, things like descriptions and that sort of thing to data, set points, units, and that sort of thing are a key capability. Computations and enrichment, so being able to actually transform data live as it's in stream, being able to create new data points from other data points, and then governance and asset definitions, so those governed and ungoverned namespaces that we often talk about, blue and red, in the way you talk about them, Walker, governed and ungoverned for us. Being able to define what an asset is and then push that through the infrastructure. And then really, Pulse today is the foundation for where we're heading. We're moving into actually delivering those insights and actions to our customers as part of our platform. And so Pulse really forms the foundation for where we're heading with those elements. And that's in agentic insights, not necessarily autonomous agents. I think that's a little ways out, but certainly agents that can interact, understand, reason over data, and then take action. So we'll talk a little bit about that as we go through and a little bit more in the fireside chat. I believe, yeah, I'm now on my demo, so I'll flip over. And Walker, give me a thumbs up if that's flipped to my new screen.
Yep, there it is.
Perfect, wonderful. So this is the Pulse interface. This is the user interface for our platform. You can see that we've started. Walker, I figured I'd keep it familiar. Oh, and of course I get signed out right as I'm doing this. I figured I'd keep it familiar. And I'd use a namespace we're both very familiar with. So I have used the Prove It 2025 namespace. I'm excited to see the 2026 namespaces as we work on those.
All three of them will be releasing for load testing next week.
Amazing. Can't wait. And I'll start with an infrastructure view. So I'll pop into this infrastructure tab here. And we can see that I have a Dallas site broker here. I've actually deployed this as HiveMQ Edge because I want to show one capability that is HiveMQ Edge specific. So I've deployed this for today's demo as HiveMQ Edge. But I'm also planning a site broker for Austin and a central broker that will live across my enterprise. And those live as draft infrastructure nodes at the moment. We'll talk a little bit more about what that looks like. And when I'm ready, I'd be able to connect those across through my actual infrastructure components. I can visualize my topology because these brokers are not currently active. I can't show the bridges, but there are bridge relationships that would exist across here. So I would be able to define where in my infrastructure I can bridge across to, how many tags I have. In this case, I have originating tags that are governed at the moment. We'll talk more about that. 724 tags for today's namespace. This could be tens of thousands or even millions. So a bit of an infrastructure view and then my ability to add infrastructure as I go along. So this is sort of the underpinnings, the data layer, the data backbone that I then add semantic context and that sort of governance layer over top of. So I'll flip back across to this namespace. And as I'm very familiar with this one, I'll go and search for line. Nope, it's not called that. It's called Press 104. So take a moment. Here we go. So I can jump into Press 104. We're very familiar with this line if you're familiar with the Prove It namespace. And we can see I have the things I would typically expect. I have some details here on that node. And actually, I want to go a little bit further, and I'm going to go find a specific tag. So we talked a lot about OEE up at the top there. So I'm going to go find, let's take a moment to refresh because I just logged out and some of this is cached. But I can see Press 104 OEE line. So I can dive all the way into that, go find my specific tags. And I can begin to see that I have data types associated with this. I have data serialization formats. If I go and look, we've got a rather not ideal OEE here, which is currently 0. If you're familiar with this namespace, you know that this specific OEE is broken on purpose so that we have something to work against for Prove It. You can see that this is being sourced from MQTT at the moment. We've got some other options here that we'll talk through. And just some sort of general data. I do also want to highlight that there is two different things here. I have a namespace path and I have a sort of MQTT topic. And those things don't have to be the same. They are, in this case, roughly the same, but they actually don't have to be the same. Within my namespace, I might want to put something somewhere that makes logical sense to me, and there might be a legacy MQTT topic that doesn't exactly conform with that. Or I might have something like a Sparkplug topic that doesn't exactly conform with that. And so I have this distinction between what the MQTT topic is and what the namespace path is. And I'm showing hierarchical relationships here. We talked about that a little bit. We're in the process of adding a series of new relationships based on feedback from our customers. So the initial things are things like process-based relationships, so that I can show process views, but we'll have other relationship types as we move along, and allow you to manipulate those in the user interface. I'll speak more on that as I go. I did want to fix OEE before we moved on, so I've recreated our OEE here in a couple of ways. So these are, I think, availability, performance, and I'll show, actually, I think quality I have as a calculation. So I'm doing quality in a little bit of a different way, which is just good count over total count. That's technically correct, although there's some better ways to do OEE, but based on the data that I have available, I'm calculating my current quality, which we can see I have very few bad units if I quickly hop around to that. Yeah, I've got relatively few bad units versus what I'm totally
And
producing.
so what you have there, for those of you who aren't familiar with the Prove It architecture, so this is the virtual factory from last year. It is based on a flexible packager. So a flexible packager basically makes packaging that go like potato chips comes in. So you're looking at the press that prints the art on the bag. The bad count is in linear feet. So that's 1,152 linear feet of bad in-feed material.
Misaligned.
And that comes from the operator. And the operator enters that data at an interval. It's not tracked in real time. The operator actually inputs that. So it is a very real, that is an industrial data problem. If I want my data in context in real time, not everything updates in real time. The operator in this case measures the linear feet and then inputs it every 15 minutes or so.
Yeah, so it'd be things like color shift or misaligned or that sort of thing, or something just didn't print, that type of thing. So what I'll do is I do actually want to get a OEE value. We can see that we actually have quite a few different calculations that have happened for this particular flexible manufacturer over the years, but I'll create a new one. Normally I'd want to fix the ones that I already have, but I think for our demo this will serve the purpose. So I'll create a new tag. I've got to give it a name, so let's call this OE_pulse just so I can find it easy. I can give it a description. I'll sort of skip along here, and I'll just call this OE-pulse. And this is just setting my MQTT topic. We can do that dynamically, but I'm setting it manually here so that it doesn't override with anything else I have. And of course, I've got to give it a data type, so I'll say decimal. And I'm creating this manually right now, but really the idea is some of this is operator driven. So when I start publishing this data, in this case it's a calculation, but when I start publishing data, we'll see later that some of these data types and that sort of thing get assigned or at least suggested automatically, or if it's coming from something like Sparkplug, then I would understand what the data type is. In this case, I'm going to serialize this as UTF-8 so I can print it in my screen. And I'll go ahead and I think I've done everything. Yep, create my tag. I'll set this as a data source of type expression. So this expression language is something we came up with. We were trying to figure out a natural way for someone who is like an OT, who doesn't necessarily want to write Python or JavaScript or anything like that. How can they write an expression? So we've done something that I think is quite cool here, which is I can actually just free type sort of like math formulas, if you will. So in this case, I'm just going to say A times P. Oh, let's keep them all at the same case. A times P times Q. There we are. And it just says, oh, okay, you want to do A times P times Q. What is the data source for those calculations? So where are you grabbing this data from? And it just dynamically
this is new.
So
this is new for me. So I'm seeing this for the first time.
Yeah, so I can use I can use simple math like this. I can also do min functions and that sort of thing. So I can do take the min of perf or something like that. Min between 1 and that. So I can do a variety of sort of mathematical operations, but I'll keep it similar. So I've got A times perf times Q, and I can store these, we're working on ways to store these and normalize these so that operator at line 1 is doing this using the same formula as operator at line 2. We're doing that based on sort of feedback from the market. So I'll go ahead and add a data source here, and I helpfully named all my tags something.
So this is the part where everybody watching. So anybody who does digital transformation, anyone who's doing the analysis, so connect, collect, store, analyze, visualize, anybody who is doing the last mile of data operations are all going, this is fucking awesome. Oh, sorry. I'm on HiveMQ's webinar. This is friggin' awesome. So anybody who does this is saying that right now.
Love it. So I've got availability, performance, and quality. I've set those as my variables. So once again, I just dynamically created that formula. I'll go ahead and create that. And we can see that within a second, it's going to take a moment because it's got to pull data. This is also a live demo, so we never really know. And this page is intended to refresh, but isn't currently. So we'll give it a second. There we are. And we see that I'm now calculating those values. This OEE isn't exactly great, but I think we live in the real world. And if we're aiming for 75, 85%.
That's normal right there.
Yeah, this is the real world.
That's the real world right there. 30%. Anybody who does MES and calculates OEE knows that when you're first getting involved with an organization, they're in the 30s. They might be in the high 20s, but they think they're in 80. They're in the 80s on paper. This is a huge part of where gains come from with manufacturers, because they think they have 82% efficiency, 80% efficiency on paper. But when you actually digitally transform, when you're actually acquiring the events digitally and calculating them digitally and not allowing it to be pencil whipped, you discover, wait a minute, we have way more room for improvement than we thought. And this is where the millions and millions of dollars of gains come from. There's just one example.
Agree.
Yeah,
absolutely agree. All right, so I've had a look at this initial value. I now want to spend some time with another node type that we have in here. So I'll actually collapse some of this, and I'll go down to this node type that looks a little bit different, which is I have a specific flexographic press here. I picked a model. I didn't know, Walker, what specific model they used, so I used a model that I've seen in the field before. But this specific expert flexographic press and central impression press. And this is an asset. This is a slightly different node type within Pulse and allows me to do a couple of cool things. So I have, I can see that, I've expanded the wrong thing here. I can see that I have some different fields. I've just quickly created these. There would be way more fields under a given asset, but I've quickly added things like my web tension actual and my web tension set point, which are data that is coming directly from the PLC that is attached to that press. I also have some additional machine details, so things like the rated speed and the serial number, which allow me to sort of understand what. If I'm trying to understand what good is out of this press, then I have a sense of what the current rated speed is for that press. So I can visualize this data output, and we'll come back to this in a moment because there's some interesting things here. But I have that serial number, that rated speed, the timestamp associated with that, which I can convert to other types of timestamps if I need to. My web tension and my web tension set point here that I can have a look at. Yeah,
very nice.
So. The way this data gets into Pulse, we're going to add many ways over time. So I could assume that this flexographic press speaks MQTT. That would be a bad assumption. That would be an untrue assumption. We live in the real world where not everything speaks MQTT, and so I might need to do protocol conversion from, say, OPC UA. I might have a gateway that does that already, but if not, we do have HiveMQ Edge, and I'll add another one of these nodes so I can show you a little bit about how that works. I'll go ahead and add an asset. I'll call this, this is my second. I'm expanding capabilities in the same line. Let's call this my expert CI2. And I can give it some description, that sort of thing. I'll skip through that for a moment.
And to answer your question, our flexographic presses in our virtual factory, they are Comexis. They are F+ series Comexi flexographic presses.
I suspect you've told me that at some other point, but I'm always sort of at the last minute trying to hack this stuff together, or hack the data together. The software is always great and robust, but my preparation is not always. History-wise, this is really important. So HiveMQ Pulse is not intended to be a historian, but I'm doing all these calculations. I'm doing all of these insights. I'm going to need some amount of data. I can't just do that off of the most recent value, the retained value. And so I do need some amount of history or the ability to tap into existing history. And this is me
especially if you want a value to be an aggregate. Especially if you want to do some type of you want to do some aggregated calculation over 60 seconds. You're not going to pump that to a historian and then pull it back, right? You're going to cache some history
exactly
in your
correct.
in your
Actually,
data
I'll go back
platform.
And show something cool related to that in just a second. So in this case, I'm currently storing. This is a new tag that I just created. I'm currently storing just one value. I'll bump that up a little bit. You can see that I can do this based on time, even at the scale of months. or I can do this as max data volume, depending on how what I'm trying to control for. But in this case, I'll just indicate that I want the last 4 data points for this new tag. And I've got to do one last thing. Oops, apologies. And just add this in here. And I'll go ahead and create this new resource. And the powerful thing that I'm ending up with is I have this asset defined here, but if I flip over to my HiveMQ Edge instance and I check out my assets and I refresh this page, and I get kicked out. Bear with me as I grab a password. Yeah, gotta have security. Sign in. I see that I have a new asset here that is waiting to be mapped. So effectively, Pulse is interfaced with HiveMQ Edge. By the way, this at some point will be another gateway type, not just HiveMQ Edge. We need to play with the existing world. Right now, we just integrate with HiveMQ Edge. And I have this option here to map the asset. I'm not going to click on that because based on some user feedback, we're overhauling the UI for this, so I won't show it to you right now, but you can imagine that I would see my OPC UA protocol adapter in this case, which is what I have present, and I have my actual fields that have come across from Pulse that I need to map those across to. So it really simplifies that job of mapping and with a push relationship that exists between those two.
Magnus, there's a quick question here that I think is a good one to answer on the fly. So Ahmed Shikali, he said, what if the input data, so when you were doing your contextualization back there, what if the input data is not published at the same time? So is it possible to create a rule to drive the calculation? So when you were doing the OEE calculation, is it possible to create a rule to drive the calculation, for example, to run the calculation only if you get X data point, but not Y?
Yeah, so if anybody watched our demo at Prove It this year, we actually had those capabilities. We had the ability to trigger based on things. With some of the changes we made, that is being reintroduced. So we're aware it's on the backlog. It's something we need to reintroduce. It's not in there at the moment. So these calculations are happening based on, for example, for the 3 inputs, whatever the most recent data I have for those 3 inputs is what I'm calculating based off of. But triggered calculations are very important to us. They're just, with some of the changes we had to make for clustering purposes, there's some challenges around that we're addressing. So if any of the 3 parameters of the calculation change, we calculate a new value, right?
Exactly correct. Got it. Yep,
exactly correct. Perfect. So that was me pushing an asset down. I want to briefly show some of the governance capabilities. And governance is interesting because I think OT teams that I've talked to get a little bit nervous when it's like, hey, is this IT who's going to be telling me what to do and what I can't do? The idea isn't that. The idea is, how do I govern what I've defined as being true? So if I'm that OT person and I've defined what this data model should look like, I want to understand if there's a deviation from that. And I can go in and I can browse through here and I'll see this rated speed, for example, is currently listed as a data type of integer. I've discovered that this is an integer, but if I go look at my actual data model, I'll see that what's coming through right now is actually rated speed is coming through as a decimal value. So what I expected to receive is different from what I'm actually receiving. That'll cause issues with downstream systems. If what I've told the downstream system is that they should expect an integer and they're getting a decimal, that'll cause challenges with those. So if I go across to this governance tab, I'm presented with my infrastructure view, and I can see that actually for this specific data model, I actually have an unexpected data format. I can click into this, and I can see I'm getting an incorrect payload that is showing rated speed as 4.1, and that I was expecting an integer. And so it's actually warning me as an OT engineer of, hey, what you've defined this data model as, or what, for example, a Sparkplug data model that has come through as a birth message, or what has come through from a UDT, whatever that has been defined as, isn't matching with the data you're receiving. And so your downstream systems are going to end up with some challenges. And from here, I can ignore or remove those alerts. So ignore basically says, if I get more of these types of alerts, I actually don't want to deal with them right now. I can then go to that ignored list and fix them in the future. I can remove these. And then 2 capabilities that we're actively working on are the ability to remediate this. So I want to be able to fix this data model. So go to that data model, other than just view a namespace, but go to that data model and actually solve this issue. Know this is going to be an integer, or sorry, this is going to be a decimal going forward, or the ability to drop these values. So instead of just saying, hey, you have a deviation, actually now I'm saying I don't want to pass this data anymore. So the ability to set rules on what happens when a violation occurs. So I'll flip back. Let's actually jump back to our namespace. I'll use this quick little shortcut. So I now have that ability to sort of govern that space. And Walker, you are very familiar with this namespace. It is yours after all.
Yep.
But you'll notice that we only have press 104. But we know, you and I know, that there's actually a press 103 and a press 105 line, and they're not
Yep.
in here right now. And this is where the last capability I'm going to talk about today comes into play. So I'll hop across to Discovery, and I'll view for this specific element of infrastructure, and we see that I actually have about 877 topics that aren't currently governed. They're not currently in the namespace's view. There's data publishing there, and that might be normal, by the way. I might have people who are testing something or people who are experimenting or just data that I don't care to govern at all, that I don't want to know about. So instead, what I can do is go, but I do want to bring in that press. So let's bring in Dallas. Press 103 is what I'm looking for. So press 103. And so now I've filtered this down to just the 256 topics that are related to Press 103, and I can go and sort of understand what's here. So I can see that, hey, this dashboard value is coming through. Pulse has made a determination that it thinks this is an integer and that that's how I should data model this. Of course, I'd have guaranteed information about this if this was a Sparkplug topic because they're actually encoded in those. But I can see here that this is an integer. It's suggesting that I serialize this as UTF-8. I can choose some other formats. Oh, actually, I can't on this one for some other reasons, but I can see how frequently these messages are coming through. First CNAT, I turned on this broker 7 hours ago. Last CNAT, 0 seconds ago. So I have some sense of that data. And what I'm approving, I can approve this into the namespace or ignore that topic. You can see I've got checkboxes here to do more. Let's have a look at a slightly more complex one. Approval runtime is an object. So I can see that I have a full object here, that it will create these fields within my namespace that will actually import these fields within my
Nice.
namespace, and the ability to understand what the data types are for those. So let's bring in that press 103 and go ahead and approve selection to namespace. We'll see that if I go across to my namespace now, I've got my press 103 that has been discovered in. I might want to retype something. So press 103 came in as just we describe it as a folder because there isn't, in MQTT, there isn't a type for a line. So I might then want to retype this. Oh, I've got my Zoom window in the way. I might then want to retype this as a line, which introduces additional capabilities and relationship understanding.
This is a very, very important feature, like the ability to go to Discovery and decide what it is we want to manage in Pulse, because one of the powers of Unified Namespace is it's red, blue, and ethereal. So red is homogeneous. These are governed objects. This is what an OEE data model looks like. This is what an asset data model looks like. Okay. Blue is heterogeneous. It's when we are enabling the citizen developer to create an object that they govern themselves, and it doesn't fit into it hasn't been promoted to an enterprise object yet. And then you have ethereal. Ethereal is we give people the ability to publish data points into a unified namespace that may only be used one time. The ethereal is if someone's listening, they get the message. If they're not listening, they don't, and no one ever knows that it was ever there. And ethereal is the thing that most data ops platforms automatically import, rather than having this ability to discover and import in and decide what you're going to govern in this intelligence layer. What they normally do is just import all the topics, and then you have to delete the ones you don't want to use. So it's a very important. It's a feature that exists that I would look for and go, oh, these are people who get the problem. Some of the problems you run into with UNS architecture is because you have those three different types of models: heterogeneous, homogeneous, and ethereal. And this discovery layer gives you the ability to decide which ones you want to manage.
Yeah, well, and specifically that idea of sort of tops down and bottoms up governance and management of as an OT engineer, there's a certain part of this that I own, and I don't want someone else to be telling me what to do. But then there are very often, if I'm doing enterprise-wide integrations, then yeah, someone from that enterprise technology team needs to be able to say, no, this is the format that I need, and you have no option around that. Being mindful of time, I think you and I got excited, as we often do, and sort of ran a little long. So I do just want to, Mohan, have you selected some questions that we can tackle? I had some other things I wanted to cover, but I think questions are the most interesting.
There's a bunch of good ones in here. There's a bunch of good ones in here.
Yes. Yeah. I think the standard one is this going to be recorded? So that's the one that I'm most qualified to answer, which is yes, it is being recorded. But I'll route the more difficult ones to you guys. Um,
Walker,
Let's
it
see.
sounded like you had one off the top of
Yeah,
your head there.
so here's the first one. A UNS architecture should help preventing vendor lock-in. Does Pulse comply to that? So I'll give my initial answer and then let Magnus jump in. Yes, it does. So Pulse is very much a node in an ecosystem. It is not a foundation of the ecosystem. It plugs into the ecosystem. It enriches the ecosystem. So now could you literally make Pulse foundational to your architecture? Absolutely. It could be the intelligence layer that sits right on top of the semantic hierarchical layer. Absolutely, you could do that, but it's not required. It is very much engineered to be a node in the ecosystem.
Yeah, I mean, I'll fully support that, which is, I mean, fundamentally the reason MQTT is a great choice for the underpinnings of Unified Namespace is that idea that many things speak MQTT. If they don't, I've got protocol translation layers, I've got all this other stuff. So I can just plug in whatever systems I want to. It isn't that everything has to become one sort of governed system. In addition, for some of the calculation capabilities, we're not trying to be the end all be all for every calculation you might ever need to do, but we do think that that information needs to live somewhere and have a data catalog and a context catalog around that. And so once some other system, be that Node Red if you're just sort of starting out and experimenting, or be that a HiveMQ or some of our other partners out there, that those data points plug back in and include the context and information that we might want from those. So certainly it's about interoperability as one of the foundational layers. So absolutely a key piece of this.
Yannick Richter asked, I'm gonna answer your question in a YouTube video on our YouTube channel because it's a long answer, but basically building UNS is a massive challenge in the OT world. That question right there, I will answer that in a long form YouTube video. It'll probably take me 30 minutes, but I will answer that question. I took a screenshot of your question. Abdi said at first you referred to the data at the edge, not likely going under operations like preprocessing, normalizing, standardization, because we need to bring data in real time. You're right, but what are the industrial ML solutions at this moment? One of the that can be used, tiny edge ML modules that are very fast computing, true. And what are the most recent solutions? Well, the reason this is an important question is it goes to where it is that HiveMQ is actually going. So the reality is that edge-based ML solutions are sorely lacking in the industry right now. Like, you can build edge-based ML solutions. Sorba AI actually has they're a great platform for doing edge-based ML solutions. So I would look at sorba.ai. But the reality is where is HiveMQ going? Like, what is the market actually missing? It's a platform for helping manufacturers actually realize the value of machine learning and artificial intelligence. And Pulse is the first step that's getting to their much larger vision. And this is something that their CEO Barry Libert and I had a conversation with on our podcast.
Yeah, and as Mohan sort of
shares, you're VP of product development now, right? So in strategy, so you obviously can answer this.
Yes. Yeah, product strategy and incubation is where I sit now. Formerly, I was an architect because, as Walker's mentioned before, my time is spent with customers and my time is spent understanding the actual problems. But now the goal is to understand how we take some of those problems and innovate over top of them. And one of the key ways we're doing that is ML at the edge, reasoning at the edge, inference at the edge, and those different pieces. And making it as sort of easy and seamless as what we saw with a calculation. So how can I take a window of data in the same way that I took those couple of OEE metrics from the Unified Namespace, something that I have present and something I have available, and turn on predictive maintenance or let's start with anomaly detection and those sort of things over a window of time. So really that's where we're heading is making it really easy for someone to, over top of the context that is available, over top of the data that is available, start doing inference, start doing analytics in a distributed way. And not from 13 different consoles based on which site I'm at, but actually just one unified platform that has the whole context of the business.
Here are two good ones. One's a little longer, one's a short, an easy one to answer. But so Alistair Dorset asked, in the case of the OE example, I understand how an MQTT topic would be read in for the calculation, but what about a case where an MES database would need to be queried to read another tag? By the way, that's a very, 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 very common use case. So Magnus, do you want to answer quickly how Pulse supports that and then I'll talk about it in UNS general.
Yeah. So Pulse at the moment, you would have to create a connector across to that from, for example, HiveMQ Edge, our gateway solution. We're looking to add more contextualization options for bringing in data from databases and that sort of thing. Those haven't launched yet, but they're certainly on our roadmap. Is how do I pull data from other systems? And then also we're thinking more about the client side of this as well, which is how do I easily create integrations from those systems into MQTT and HiveMQ. So that isn't my area. This is something else we're thinking about. But our thinking is always, if this data is needed in the unified namespace, then we need to make it really easy to get data into the unified namespace.
So
ultimately,
what
they'll be represented as part of the catalog.
Yeah, what Pulse is it's an intelligence platform that sits on top of your we're going to say on top of your unified namespace, but it doesn't just sit on top of a UNS. You can actually build a unified namespace inside of Pulse. So, but what it is, it's an intelligence platform that sits on top. The IIoT platform, which is the one that does connect, collect, store, analyze, visualize, that's the place where you would consume from the database, and then you would put it in tag structure, or you would put it in an MQTT topic structure, and then Pulse is a node that is going to do something with that.
Exactly
and then
correct.
from an Sylvain Forms asked, from an IT perspective, this is a question you're going to get a lot. Does HiveMQ support bulk data configuration, or does it need to be added one by one? Obviously, for scale, configuration's key. So Magnus, go ahead.
Yeah, exactly. So you saw UI, but of course there are APIs, and we're again looking in from feedback like yours, looking into some other ways to do that at scale. We're exploring things like domain-specific languages. We're exploring things like, by the way, allowing large language models to configure some of this. But certainly there are APIs available for all of these things. I just showed through a UI here today. So bulk data absolutely supported. And then of course, because this is the other question that goes with that, is how do I then get that data into my upstream systems if there's more complex analytics I need to do? That's our existing extension infrastructure and our ways that we move data today.
And Mohan, can we do one more? So Matthew Parker,
yes.
we're going to answer. I'll answer your question if the line is running. However, various states are manually captured. The TPM question, I will answer that in a YouTube video also, because that's not it's not just a Pulse response. But I do want to do this one right here. Luis Iriarte, this is a good question because this is going to be a common application. How could HiveMQ Pulse plus Model Context Protocol servers, MCP servers, together help integrators like Copar? They're an integrator based in Mexico that works in Tier 1 primarily. They deliver truly plug-and-play digital factory solutions where data models self-discover, synchronize, and maintain context across all systems without extra integration work. This is kind of exactly the direction HiveMQ is going, and I think it's a good last question. But do you want to go ahead and answer that, Magnus?
It's a fantastic one. So I mean, this is absolutely the direction we're heading in. We actually already have some very functional prototypes. Maybe we'll have a sneak peek at Prove It. I'm hoping we will in February. That's a little plug for Prove It 2026. But certainly MCP, it plays a critical role here. We need those large reasoning models and small reasoning models, small language and small reasoning models at the edge to be able to interact with Pulse. So MCP is a key part of that. And we have, there's a sneak peek demo that we can do of doing some of those integrations as well. And certainly at Prove It, I hope to have something to show.
And how do people get their hands on Pulse? That's the obvious question here.
Yeah, thanks for asking. So, I mean, and this is, we're currently in release. If our customers want to get in touch with their account teams, they can. Given that this is a new product for us, we're having to roll that through an account team. In the new year, we're looking to figure out self-serve and really everything you talked about with Barry in your podcast. I recommend everyone go watch that. How do we make it easier for our customers, regardless of budget authority, regardless of size? How do we make it easier for our customers to consume HiveMQ, all of HiveMQ's products, not just Pulse, but certainly we're moving in that direction of how to make it easier to self-serve across our platform. So today, get in touch with your account teams. I know many of you are on this call, but very soon, keep your eyes peeled for self-serve capabilities.
Awesome.
And with that, I want to make.
By the way, that was a popular response. Look at all that.
Yeah, clearly, yeah.
Yeah, no, I'm going to make the unpopular call to end this webinar here. But love seeing this passion, love seeing all the questions. And just as an FI to reiterate, like the webinar is being recorded. We have all your questions. So the ones that we could not get to, we will answer them offline later. Walker, this was fantastic. Thank you so much for the passion and the insights and the enthusiasm and the partnership. And Magnus, once again, always a pleasure.
Always a pleasure. Thanks, Mohan. Walker,
And thanks,
love
everyone.
Awesome
chatting
job.
with you. Let's do it offline more. Let's do it online more.
Let's do it,
Whatever
man.
works.
And for
Great.
those of you who are interested, prove it. Come to prove it in February 16th to the 20th. You can go to proveitconference.com if you want to see HiveMQ's big announcement that they had I know that they have for February.
Love it.
Thanks, everyone.
Thanks,
Bye-bye.
everyone. Bye for now.